A normal takeoff occurs when the aircraft is departing into a direct headwind from a paved surface with plenty of runway distance available and with no obstacles close to the end of the runway. Taking off directly into the wind allows the aircraft to take off using the least amount of runway. This is essentially because the wind is giving extra airflow over the wings, so the aircraft doesn't need to travel as fast to get to the same airspeed recommended for takeoff. At this point in your training, we are going to go over a simplified procedure for takeoff to get the general idea. However, you probably will find it helpful to practice the full procedure, which mostly just consists of additional callouts. We will be going over the full procedure in a future lesson. The takeoff procedure begins with safely entering the runway. Before ever crossing the hold short marking for the runway, the pilot needs to always visually scan the entire runway length, as well as the arrival and the departure paths, to ensure no hazards like other aircraft or vehicles exist. Secondly, the pilot should also confirm they are entering the correct runway. Verbally brief what runway you are entering, and confirm with your instructor which direction you will be taking off in. If you're at a towered airport, make sure your runway is in agreement with the clearance given by ATC. As you taxi out onto the runway, position the plane on the runway center line. Then, confirm that the heels of your feet are on the floor and off the brakes, so you don't accidentally step on them. Just like when taxiing on a taxiway, you want the runway center line to line up with your right leg. Once you are lined up on the correct runway, smoothly apply full power. The adding of power should take about 2 seconds. If you add the power too quickly, the engine could backfire, adding power too slowly, and you risk wasting available runway. As the Cessna starts to accelerate down the runway, you may notice a tendency for the plane to turn to the left. You will need to add a slight amount of rudder to counteract this and keep the airplane on the center line. Continue to make small rudder pedal inputs to maintain the aircraft on center line. Make the inputs as soon as you start seeing the airplane drift from the runway center line. Waiting too long to correct could result in a runway excursion. Once full power is applied, quickly glance inside to check the engine instruments, making sure all of the indications are in their normal parameters. As the airplane continues to accelerate, make sure that both of your airspeed indicators are indicating speed above 0 and increasing. Keep in mind, however, that the G1000 will not indicate an airspeed less than 20 knots. If anything out of the ordinary is indicated, the best course of action would be to abort your takeoff. Once you've exited the runway and come to a complete stop, you can then safely troubleshoot the problem. However, under normal conditions, you will continue to accelerate to 55 knots. As the airspeed is increasing, the controls will become more effective. This is due to the increase of air flowing over the control surfaces. Most notably, the airflow under the elevator will actually bring the surface into its neutral position. You will feel this happening as the yoke slides aftward, towards you. Once the airspeed reaches 55 knots, it's time to pitch up and begin your climb. This procedure is called rotation. To rotate, smoothly increase back pressure on the yoke, raising the nose until the tip of the engine cowling touches the horizon. This is roughly 9 or 10 degrees of pitch up. Maintain this pitch attitude as you continue to climb out. The goal is to maintain 74 knots. This is the airspeed that gives you the best rate of climb, and is also known as VY. You should visually confirm you are climbing using outside references, and that your vertical speed indicator is showing a positive value. Next, while climbing out, you should momentarily step on the brakes. As your wheels lift off the ground, they will continue to spin, and this spinning usually results in vibrations. Now that you're airborne, it's important to continuously look outside for traffic and terrain clearance. Remember, 90% of the time, your eyes should be looking outside. When the aircraft is at least 200 feet above the ground, briefly lower the nose toward the horizon to ensure that there is no other traffic in your flight path. Once the area is deemed clear, resume the VY pitch attitude. At 500 feet AGL, lower the pitch to increase the airspeed and continue to climb, now at 85 knots, which is our cruise climb airspeed. At Embry-Riddle, we climb at 85 knots because it allows for better visibility in front of us and better cooling for the engine. If you ever need to climb at a higher vertical rate of climb, do not hesitate to increase the pitch and climb at 74 knots instead. Ideally, a pilot always tries to take off with a direct headwind. However, this very rarely happens. Almost always, there will be some crosswind component. Since crosswind takeoffs occur so often, it's important to develop this skill relatively early in your flight training. The correction required during takeoff is very similar to that required during taxiing. If the crosswind is coming from the left, the yoke gets pointed to the left. By doing this, the left aileron is deflected up, creating a downward force on the left wing and preventing that wing from rising too early. The opposite would happen with a crosswind from the right. When lining up on the runway, you should apply full aileron correction into the crosswind. Remember that as the airspeed increases, the controls become more effective. Therefore, as the ailerons become more effective, the pilot needs to reduce the aileron input. Otherwise, you'd be overcompensating for the crosswind. To keep the takeoff path straight down the center line, rudder force will also be necessary. This is because a crosswind condition will cause the airplane to weather vane, or turn into the wind. Remember that with a normal takeoff where there is no crosswind, you need right rudder. Now, with the crosswind, things change slightly. If the wind blows from the left, additional right rudder will now be required to compensate for the airplane's tendency to weather vane to the left. However, with a right crosswind, less right rudder will be required as the weather vaning tendency to the right will oppose the left-turning tendencies. As the airplane is accelerating down the runway, the relative crosswind component never becomes zero. Consequently, aileron input will be used throughout the entire takeoff. With improper crosswind correction, the airplane may begin to get pushed off centerline. This side loading causes stress on the landing gear, so it's important to use aileron correction throughout the entire takeoff roll. As the airplane lifts off the ground, the downwind wing and wheel should rise and lift off the runway first. If gusty winds exist, the rotation may be slightly delayed in order to allow the airspeed to rise, allowing a definite takeoff without settling back onto the runway. Once the airplane is in the airplane should remain on the extended runway centerline just like a normal takeoff. A crosswind takeoff and climb is very similar to a normal takeoff and climb except for control input. Simply put, a crosswind takeoff requires additional aileron and rudder inputs in order to keep the airplane on the centerline with wings level. Crosswind takeoffs require finesse, but you'll have plenty of time to practice these during your flight training.
Departing from a soft or grass field comes with its own unique set of challenges. Proper technique is required from the moment you begin to move the airplane from its parking location until you are safely clear of any obstacles and established in a normal climb. Before you begin to taxi the airplane on any soft surface, remember to hold the yoke fully aft to minimize the weight on the nose wheel, thereby keeping it from becoming stuck in the turf. At the same time, you must also apply proper crosswind correction, just as you would during taxi operations on a paved surface. With a soft field takeoff, it is important to remember that the performance of the airplane will be reduced by the increased friction with the soft surface. Be sure to calculate your takeoff data and evaluate it against field and weather conditions to be sure that you can safely depart and clear any obstacles. Prior to entering the runway for departure, ensure that the before takeoff checklist and before takeoff final items have been completed. Don't forget to set the flaps to 10 degrees. As you enter the runway, hold the yoke fully aft and position the flight controls in the appropriate direction for the wind conditions. Minimize your use of braking and keep the airplane rolling so that it doesn't become stuck in the soft surface. Make the appropriate call-out once you have verified that you are on the correct runway. As you line up with the runway centerline, smoothly apply full throttle. As you are applying the power, the elevator will become effective almost immediately, so it will be necessary to relax the back pressure on the yoke in order to prevent a tail strike. For a pitch reference, try to keep the nose of the airplane aligned with the treetops at the end of the runway. Check that the engine instruments and tachometer are in the green and make your callouts.
In the green.
As the airplane accelerates, maintain directional control and the runway centerline with the rudder pedals. As your speed increases, you will need to continually relax the back pressure on the yoke to maintain that same pitch attitude until the airplane lifts off the ground. Because of ground effect and the use of flaps, the airplane will most likely become airborne at a very low airspeed, even below stall speed. You do not want to climb out of ground effect, or you could stall the airplane, and since you'd only be a few feet off the ground, well, that would not end well. As the main gear lifts off the ground, push forward on the yoke to keep the airplane in a level flight attitude, hovering in ground effect just a few feet off of the ground. If there are no obstacles at the departure end of the runway, accelerate to obstacle clearance speed while in ground effect, and then establish a VY pitch attitude and climb out. If, however, there are obstacles to be cleared, accelerate to obstacle clearance speed while in ground effect, then pitch for and maintain that speed, climbing out until the obstacles have been cleared. Once the obstacles have been cleared, pitch for VY. With a positive rate, depress the brake pedals and make your call out. Once the airplane has accelerated above 65 knots, retract the flaps to 0 degrees and maintain the VY pitch attitude. From here on out, continue climbing using the normal takeoff procedures. Now that we've covered how to fly the maneuver, let's look at the end goals for your skills in a soft field takeoff. Some of the standards for the end-of-course check ride include: ensure the aircraft is properly configured. Clear the area, taxi into takeoff position, and align the airplane on the runway centerline without stopping while advancing the throttle smoothly to takeoff power. Establish and maintain a pitch attitude that will transfer the weight of the airplane from the wheels to the wings as rapidly as possible. Lift off at the lowest possible airspeed consistent with safety and remain in ground effect while accelerating to VY or VX as appropriate. Establish a pitch attitude for VY or VX as appropriate and maintain that selected airspeed plus 10 or minus 5 knots during the climb. Maintain takeoff power and VY plus 10 minus 5 knots to a safe maneuvering altitude. Complete the appropriate checklist. Now that we've covered some of the basics of the short field approach and landing, it is time to take an in-depth look at the procedures required for the maneuver. A short field approach and landing is used at fields where the runway distance is relatively short, or the approach is made over obstacles that limit the available runway for landing. As with all other maneuvers, there are certain criteria that you will be expected to meet for the end-of-course check ride. As with any other type of landing, you must first prepare your airplane by completing the descent checklist prior to beginning your approach. This will ensure that the airplane is set up and will keep you from any extra distractions. Hello? Mom, I can't talk right now. I'm kind of in the middle of something. Yeah, no, I'm in the booth. I'm recording right now. Can I call you back? All right, fine. No, yeah. Yes. I love you too. All right, yeah, I'll call you in a little bit. That will keep you from any extra distractions during your final approach. As you approach the airport, use either the traffic pattern procedure outlined earlier or the instructions given to you by ATC to position the airplane on downwind and select the point on the runway where you intend to land. This point could be a particular runway stripe or marking, or even the intersection of an adjacent taxiway. Remember that your aiming point needs to allow you to safely remain clear of any obstacles on the final approach path, while leaving you enough remaining runway to safely bring the airplane to a stop. Prior to departing on your flight, you should have calculated both the ground roll distance and total distance to clear a 50-foot obstacle. Planning your approach and touchdown point is critical for this maneuver because the short field approach and landing is all about accuracy. Since the goal of this maneuver is to accurately land the airplane on or just beyond your aiming point, you should be making small adjustments during your final approach to keep the airplane tracking toward your aiming point. For example, if it appears that you are too high and will land beyond your aiming point, you will have to simultaneously reduce power and lower the nose. This will allow you to increase your rate of descent while maintaining your desired approach airspeed. If, on the other hand, you appear to be too low and will land short of your point,
Simultaneously increase power and raise the pitch slightly to reduce your rate of descent without gaining excessive airspeed. Carrying excess speed into the flare will cause the airplane to float through the landing. If you're landing on a short runway, the last thing you want to do is touch down without enough runway surface remaining to safely stop. Allowing the airplane to become too slow is equally as undesirable, however, because you could find yourself operating without sufficient power to overcome the excessive drag. This could result in a stall, or very hard landing. Once you're on final approach and a safe landing is assured, set the flaps to 30 degrees and adjust your airspeed to 61 knots plus half the gust factor. At this point, the airplane will be operating behind the power curve, so it is important to maintain a stabilized approach. Make all of your callouts as you would for any other landing. Runway 23 verified. Stay around. Compared to a normal approach and landing, the roundout and flare for a short field should be executed somewhat differently. Begin your roundout earlier, around the top of the trees, and this time slowly and continuously reduce the power to idle, while at the same time increasing the pitch to maintain the same glide path directly toward your aiming point. This type of approach and landing can be tricky to master, so look for visual cues to help you determine when and how to flare. The first visual cue you will notice is that the runway will begin to flatten out in front of you. Up until this point, you have been looking down at the runway. Once you reach that same altitude as the top of the trees where you begin the roundout, you will see less and less of the surface of the earth in the distance. This same point is when you want to transition your focus out towards the end of the runway. If you focus your eyes too closely to the nose of the airplane, you will tend to have a flat and firm landing. Keep your eyes out towards the horizon and use your peripheral vision to spot the location of your aiming point. As you flare the airplane, be sure that the power is at idle and continue to smoothly increase the pitch. Your airspeed should decrease as you do so, and you may even begin to hear the stall horn. This decrease in speed and increase in pitch will allow you to touch down on the main wheels at minimum controllable airspeed with little to no float and the airplane in the power-off stall pitch attitude. Visually, you should be touching down with the nose of the airplane touching the tops of the trees in the distance. This will be high enough to keep you from landing on the nose wheel while at the same time aiding in aerodynamic braking after the mains have touched down. Once the mains are down, allow the nose wheel to gently touch down and retract the flaps to 0. This will help transfer the weight of the airplane from the wings to the wheels and will allow the brakes to work at maximum capacity. Continue to pull back smoothly on the yoke until it is fully aft so that the elevator works as an aerodynamic brake. At the same time, apply the maximum braking required to bring the airplane safely to a stop without skidding the tires. The last thing you want is to blow out a tire on the runway. Maintain directional control with the rudder pedals, and remember to increase any crosswind corrections as the airplane slows and transitions from flight to taxi. Now that we've covered how to fly the maneuver, let's look at the end goals for your skills for a short field approach and landing. Some of the standards for the end-of-course check ride include: complete the appropriate approach and landing checklist. Consider the wind conditions, landing surface, and obstructions to select a suitable touchdown point. Establish the recommended approach and landing configuration and airspeed, and adjust pitch attitude and power as required. Maintain a stabilized approach and recommended airspeed with wind gust factor applied, +10 or -5 knots. Touch down smoothly at an appropriate airspeed. Touch down within the available runway, at or within 200 feet beyond the specified point, with no side drift, minimum float, and with the airplane's longitudinal axis aligned with and over the runway centerline. Maintain crosswind correction and directional control throughout the approach and landing sequence as required. Execute a safe and timely go-around decision when the approach cannot be made within the tolerances specified above or for any other condition that may result in an unsafe approach or landing. Apply brakes as necessary to stop in the shortest distance consistent with safety.